Welcome back. Episodes 1 and 2 built the ideas, the two-brain agent, the detective, the judge, the unsat core. Today the training wheels come off, just slightly, because today we write code. 10 constructs. Each one fits in 20 lines or fewer, each one runs exactly as you see it, and together they cover about 90% of everything I do with Z3 in production systems. If you have never written Python, stay anyway. You already understand what every one of these pieces is for, today just gives your intuitions their names. Setup first, and it is genuinely one line, pip install Z3 solver. That single package carries the whole solver, precompiled, no build steps, no dependencies to fight. Then one import at the top of your file, and you have everything. Here is the map for the next 10 minutes. Constructs 1 and 2 declare unknowns, the yes-no switches and the numbers. 3, 4, and 5 are the courtroom workflow, file the constraints, demand a verdict, read the witness. 6 and 7 let you combine rules the way policy documents combine sentences. And 8, 9, and 10 are the power tools, the written judgment, the thought sandbox, and optimization. One rule holds for the whole episode, every snippet fits on a single slide, and every snippet runs exactly as shown. Nothing is pseudocode. If a slide claims an output, that output came from actually running the code. Constructs 1 and 2, declaring unknowns. A bool is a yes-no switch, exactly the switches from episode 2. Does Alice work the morning? One line, Alice_m equals bool of that name. An int is a whole number unknown, like hours. A real is a decimal unknown, like an hourly rate or a pay total. Now, the single most important mental shift in this entire episode, so let me slow down for it. These are not Python variables. They do not hold values. Think of them as empty seats in the courtroom, seats the solver will eventually fill. You never assign to them. You will never write hours equals 8. Instead you will state facts about them, hours is at least 8. The difference sounds subtle and is everything. In normal programming you compute values, with Z3 you describe a world, and the solver finds the values. Once that clicks, the remaining 8 constructs are almost obvious. Constructs 3 and 4, the courtroom workflow. Solver, with a capital S, creates the court. And then s.add files a constraint, hours is at least 8, rate equals 42, pay equals hours times rate. Notice that double equals sign, it is not assignment, it is a statement of fact, a claim that these quantities are equal in any acceptable world. And here is a point that trips up every newcomer, so hear it now, add never computes anything. You can file 1,000 constraints and the solver has not lifted a finger. It is a filing cabinet. All of the work, the entire detective search from episode 2, the propagation, the conflicts, the learning, all of it happens inside one call, s.check. And check returns exactly the 3 verdicts you already know, sat, a solution exists, unsat, provably impossible, unknown, out of budget. 2 constructs, and you already have a complete working session with the judge. Construct 5, reading the witness. When check comes back sat, the solver is holding a complete solution, and s.model hands it to you. Index it with your unknowns, m of hours, m of pay. For our little pay setup that prints 8 and 336, 8 hours at $42. Remember what a model means from episode 2, it is a witness, one concrete world in which every filed constraint holds simultaneously. And it has a lovely property, you do not have to trust the solver. Substitute the numbers back into your constraints yourself, by hand, and watch each one hold. Verification takes seconds and requires no faith. For an agent, the model is not a diagnostic printout. It is the executable output, the roster to post, the set points to apply, the repaired plan to hand back to the language model. SAT plus model is the happy path of every guardrail we will build. Constructs 6 and 7, combining rules. And, or, not, three connectives that read almost like English. Alice and Ben never share a shift becomes not of and of Alice morning and Ben morning. It is nearly dictation. And then implies, the if-then arrow, which I would argue is the single most important construct for knowledge work. If it is a weekend, the rate is at least 5250, implies of weekend, rate at least 52.5. One line. Pause on why this matters beyond syntax. Open any policy document, any award, any clinical protocol, and look at the sentences. If the patient is over 65, reduce the dose. If the shift crosses midnight, apply the night loading. Unless both conditions hold, the discount does not apply. Nearly every clause is an implies. Nearly every exclusion is a not of and. Which means you already know how to read rulebooks in Z3, you have been doing it your whole professional life, just in prose. Now the payoff. Remember the roster puzzle from episode 2, the one you solved by hand and got stuck twice? Here it is, settled, in 14 lines. Watch the whole pipeline run. 6 bools, 1 per person per shift. One small helper that counts how many switches are on, so that exactly 2 per shift becomes a sum equaling 2. Then the 4 house rules, and look how directly they translate. Alice and Ben never share, not and, twice, once per shift. Chloe works mornings only, not of Chloe evening. Every shift staffed by exactly 2, the 2 counting lines. Nobody works both shifts, 3 more not ends. Then 1 call to check. Output, unsat. The machine reaches in milliseconds, with a proof, the conclusion that took us 2 failed attempts by hand. And notice what the side panel says, because it is the real lesson, exploration is now free. Wonder what happens if Chloe could work evenings. Delete 1 line, rerun, and the verdict flips to SAT with a roster attached. The cost of asking what if has collapsed to nothing. Construct 8, the one this whole series has been promising, the unsat core, in code. 2 small changes to what you already know. First, switch the feature on, s.set, unsat_core equals true. Second, instead of plain add, use assert _and _track, which files the constraint and attaches a name tag, R1, R2, R3. These are episode 2's 3 pay clauses, the 25% loading, the $400 cap, the 8 hours at $42. Check says unsat, as we knew it would. But now ask s.unsat_core, and back comes the written judgment, R1, R2, R3. The minimal set of named clauses that cannot coexist. In an agent, those names are not labels for humans only, they are keys back into your knowledge base. Log the core, cite the exact clauses to the user, hand the language model precisely the rules it violated so it can repair the request. Veto with receipts. Episode 4 is essentially this one construct, deployed against real Australian award rules. Construct 9, push and pop, the thought sandbox, and the analogy I promised back in episode 1. Picture a stack. At the bottom sits your case file, the permanent rules, filed once. Now the agent wonders, what if the shift ran 10 hours? You do not want that speculation contaminating the case file. So, push. A new transparent layer opens on top. Add the what if there, call check, read the verdict. Then pop, and the layer vanishes, the speculation is forgotten, and the case file underneath is exactly as it was. Why does this matter so much for agents? Because planning is a stream of what-ifs. Try Shift A before Shift B. Add a second driver. Delay the maintenance window. Each is a push, a check, a pop, hundreds of disposable thought experiments per second against one stable set of ground rules. And here is the quiet bonus from episode 2, the lessons the solver learns during those experiments, the learned conflicts, largely carry over. Every discarded daydream still makes the next one faster. Construct 10, the last one, optimize. Everything so far asked, is this possible? Optimize asks the more ambitious question, among all possible worlds, which is best? And the syntax is almost insultingly small. Swap solver for optimize, keep every add exactly as before, and speak one new verb, maximize, or minimize. Our example, hours between 8 and 12, pay at the loaded weekend rate, a $600 budget cap. Maximize pay. Watch the dial climb. It rises through the feasible region, hits the boundary where the budget bites, and settles, 11 hours, $577.50. And this is the part to savor, that answer is not a good heuristic guess. It is a proof. No assignment inside those constraints pays even 1 cent more. And with that, the vocabulary is complete. 10 constructs. Everything you will see for the rest of this series, the linting, the guardrails, the plan verification, the 4C layer, is these same 10 pieces, composed. Here is the whole episode on one screen, and yes, this slide is designed to be screenshotted. Constructs 1 and 2 declare the unknowns. 3 through 5 run the courtroom, file, verdict, witness. 6 and 7 combine rules like sentences. 8, highlighted, is the written judgment, the construct that makes vetoes auditable. 9 is the thought sandbox. 10 turns feasible into optimal. 10 pieces. If they feel small, that is the point. The power is not in any one construct, it is in how fearlessly they compose, and composition is exactly what the rest of the series is about. 3 ideas to carry forward. 1. With Z3 you never compute, you describe. Declare unknowns, file facts, call check, and let the solver do what 40 years of research taught it to do. 2. Names make vetoes auditable. 1 construct, assert and track, turns anonymous constraints into citable clauses, and the unsat core into a judgment your agent can put in writing. 3. 10 constructs, infinite reach. You now hold the complete working vocabulary for everything ahead. And next time, we finally cash the check this series has been writing since episode 1. Episode 4, Linting the Knowledge Base. Real Australian Award Rules, compiled to constraints. Real conflicts that nobody spotted in prose. And the unsat core, earning its keep on a problem that costs real businesses real money. Bring the cheat sheet. See you then.